castings. They'll like have a casting block that'll make like, 100 Matchbox cars at a time. Maybe we just make that real big.
Finally spotted here at Tesla's Fremont factory, Elon Musk's 2026 Tesla Model 2 has been captured in what might be the most jaw-dropping leaked footage yet. And what when discovered inside this prototype will absolutely shock even the most dedicated Tesla enthusiasts just months after he boldly declared, and I'm confident that will be, available in many cities in the US by the end of this year. It's especially not just a revolution in vehicle design, but a breakthrough in vehicle manufacturing. So, what's really inside this highly anticipated model to make Elon Musk announce that this is a game-changing revolution in vehicle design and manufacturing? While other videos or titles show you surface-level spy shots, we're diving deep into the technical DNA that separates this from every Tesla that came before it. And you won't find this stunning breakdown on Tesla's website or any mainstream news outlet. If you're ready to uncover what legacy automakers and Chinese EVs don't want you to discover, you're in the right place. We're aiming for exactly 135,759 informed subscribers, not followers. So turn on that bell and subscribe here because you'll never want to miss a real drop like this again. 1. How does the wheelbase reveal a shocking shift in Tesla's chassis engineering? Looking closely at this leaked prototype image, we can clearly see that Tesla is using front and rear wheels placed extremely close to the edge of the body, leaving the suspension with virtually no room to absorb longitudinal forces. This isn't just a design choice. It's proof of a complete engineering revolution happening inside Tesla's walls right now. When we measure the ratio between the axle and the front and rear of the car based on this image compared to the Model Y sitting right next to it, the distance from the front axle to the front of the car is only about 540 to 580 millimeter, and the rear measures approximately 490 to 520 millimeter. Here's where this gets absolutely mind-blowing. The Model 3 has the same distances at approximately 855 mm in the front and 835 mm in the rear, respectively. Meaning Tesla has reduced the overhang by nearly 300 mm at each end. 300 mm might not sound like much, but in automotive engineering, that's an industry unthinkable number that breaks every rule we thought that we knew about vehicle architecture. Traditional suspension systems need at least 700 to 800 mm of space from the axle to the nose of the car to accommodate critical assemblies like suspension joints, cradles, auxiliary drivetrains, crash boxes, and dynamic deformation buffers designed to save your life in collisions. With the distance reduced to just 500 mm, Tesla no longer has enough room for old-fashioned mechanical structures. That can only happen if Tesla integrates the entire suspension and drivetrain into the GigaCast front and rear blocks and eliminates all traditional subframes, cradles, and mounts, exactly like Tesla is doing with the drive unit in the Cybertruck. This is a feature only seen in cars using unibody gigacasting, where the front and rear body blocks are cast together with the suspension system and the motor drive unit is directly attached. Tesla is taking gigacasting to the next level beyond simply a load-bearing frame. They're creating a monolithic drivetrain frame that integrates the entire drivetrain into the chassis itself. This eliminates the entire cradle crossmember and most traditional mechanical connection points. This is a design philosophy only seen in Le Mans race cars, never before attempted in a civilian electric vehicle. This confirms that the Model 2 fits perfectly into the A+ and B hatch segment with the ability to turn around in a radius of less than 5 m, which is ideal for urban Europe and the USA. Could this be the first mass-market EV to use Lemon-style drivetrain casting for everyday city driving? Drop the word wheelbase in the comments if you believe what we just saw is not a design coincidence, but a declaration of war on how every car is built today. And keep watching because what we reveal next about the rear roofline geometry will completely transform how you think about Tesla's manufacturing strategy. 2. Why is the rear roofline geometry a hidden hint of modular swappable roofs? In the prototype image, especially the roofline from the B-pillar to the rear of the car, we see something unprecedented in Tesla's design language. Instead of being continuous like the Model Y or Model 3, the roofline breaks sharply at the C-pillar, creating an angle of nearly 20 to 25 degrees between the upper roof and the rear glass. This isn't an aesthetic choice. It's engineering evidence of something revolutionary happening beneath the surface. In Tesla's traditional design philosophy, the roofline maintains a minimum curvature radius of 5 to 3, 2m, spreading evenly from the front glass to the rear glass to optimize aerodynamics. But in this prototype, the curvature radius after the SE-pillar is almost zero, appearing almost like a floating roof block that's been separated from the body. The obvious gap between the SE-pillar and the rear spoiler, estimated at 55 to 70 mm based on the 17 in wheel ratio, is not found in any previous Tesla model. And that gap is the smoking gun. These signs reveal that the rear roof is not a solid block, but a separate module that's removable or interchangeable. This could be the first physical manifestation of the modular roof architecture strategy that Elon has hinted at since 2021, but has never applied to any vehicle model. The capabilities this structure enables are staggering. The standard version could use a single-layer laminated metal roof, costing only about $85 to $110 per roof, while the upgraded version uses a full-glass roof costing approximately $320 to $380 that fits into a fixed frame. The high-end version could feature a solar panel roof with a capacity of 180 to 210 watts integrated directly into the module, costing about $600 to Connery. $750. The entire roof system only needs to be connected via 4 to 6 mechanical pins, plus 1 data plug-in cable and 12 VT power. Similar to the Cybertruck roof tent mounting mechanism, changing the roof takes less than 15 minutes in the assembly line or service workshop. The snap-on module design even allows for a removable rear spoiler mounted at the CPLR brake, easily removable. So, the base version doesn't have it, while the premium version adds it, helping reduce the drag coefficient to approximately 0. 21 to 0, 22, 22, equivalent to the Model 3. With this architecture, Tesla achieves something unprecedented in urban electric vehicles. 1 chassis, 3 roof variants depending on the configuration. This reduces the price of the low-end version while increasing the profit of the high-end version without changing the body frame. Do you think Tesla is really preparing to let us upgrade our roof modules just like we swap phone cases? Drop the keyword rear roofline in the comments. If you think what we're seeing here is more than just design, it's the future of customizable electric vehicles. And if that shocked you, wait until you see what Tesla has done with the back quarter panels. Next, you'll see what we've discovered about those unusual rear quarter panel cuts. They reveal Tesla's most ambitious manufacturing strategy yet. 3. How do the unusual rear quarter panel cuts point out Tesla's new manufacturing strategy? Now, turn your eyes to the area behind the left rear wheel, and you'll notice 2 extremely clear vertical panel lines that completely separate the rear end from the main body. This has never appeared on any previous Tesla model, including the Cybertruck, and it's revealing Tesla's most ambitious manufacturing strategy yet. On the Model 3 or Model Y, the entire rear end from the taillights and wheel arches to the lower bumper is stamped and welded into one piece. But on this Model 2 prototype, the rear panel is divided into at least 2 separate parts, and the implications are staggering. The first is what we're calling the lower rear module, including the entire rear bumper, taillights, radiator grills, if any, and potentially integrating a 12V or 24V auxiliary battery or reverse Kaiman. Sensor controller. Based on our photo analysis, the estimated dimensions are 1,350 to 1,400 mm in width and 400 to 450 mm in height from bottom to tie. The first cut. This module is designed for quick removal in under 15 minutes with just 6 to 8 fasteners plus one signal light connector. The estimated replacement cost of this panel is only about $120 to $180 for plastic or $30 to $350 for integrated vertical cool LEDs like Model 3 Highland. The second component is the upper panel or upper hatch module, which includes the rear window frame, trunk hinge, spoiler if equipped, air vents, and rear camera. This section measures approximately 750 to 800 millimeter long, extending from the SEPIL-R to the rear trunk edge. It can be removed by opening the rear window plus roof hinge, similar to the European hatchback design, allowing Tesla to produce multiple versions easily. The base version has no spoiler, while the premium version adds aerodynamic spoilers, sport grills, or wide-angle cameras supporting full self-driving capabilities. This is a breakthrough because Tesla is applying a strategy called service C-centric panelization, which is only found in supercars like MC Laron with their rear bumper separate modules. Light electric trucks like the Ford Transit and Rivian EDV, and some industrial electric vehicle concepts from Renault and BYD. According to the National Highway Traffic Safety Administration, 47% of urban crashes under 40 mph are rear-end collisions. And the average repair cost for a Model 3 rear is $1,842. With a modular unit like this one, that cost could drop to under $400. For low-income customers in the United States or Europe, the ability to quickly replace panels at local service centers or do it yourself at home with basic tools makes the Model 2 the first Tesla car that's, quote, truly for the masses. Even after a collision, Tesla isn't only optimizing production costs. They're optimizing after-sales costs, which will put Chinese automakers like BYD or MG in an impossible position because they still use welded frames that are expensive to repair. That's game-changing for anyone on a limited budget. Tesla is not just optimizing production. They're optimizing the entire life cycle of the car, from assembly to accident to the aftermarket. Is this the moment Tesla truly becomes the people's EV? Not just because it's cheap to buy, but finally cheap to repair. If that possibility excites you, go ahead and comment modular rear down below. Let's see how many of you believe this design shift is the real revolution. But there's one more smoking gun piece of evidence that confirms everything we've just revealed, and it's hiding in plain sight with that white paint pattern. 4. Why is the light paint pattern entirely the sign of new manufacturing trials in Fremont? The white paint pattern on this prototype isn't just a color choice or a wrap, but the official paint on the body. And Tesla may be testing what we believe is Heat Shield White, a new electrochemical paint that reduces cabin temperature by up to 17.6 degrees F when parked outdoors. This could reduce air conditioning power consumption by up to 13%. And with cheap cars running small batteries, direct cabin cooling increases range by 5 to 7% in summer conditions. But looking closer at this white prototype reveals something extraordinary. The entire mid-body of the car has been painted a completely glossy white, while the front and rear sections are still covered in camouflage fabric. Here's what makes this revolutionary. There are no decals, no dividing lines, no wrap lines between the painted and unpainted areas. Tesla isn't wrapping, isn't using fake stickers, isn't painting the whole body and then re-wrapping. They're only painting the mid-body section. This is the first evidence that Tesla is implementing the partial body painting strategy, a massive breakthrough in automotive production. Current paint shop lines in Fremont take 42 to 45 minutes to paint an entire car through spraying primer, main color, clear coat, and drying the whole body. But by painting only the center body shell, which accounts for approximately 60% of the paint surface area, Tesla can eliminate rotation delays and the difficult front-rear drying step that requires even heat distribution. Total paint booth time is reduced by approximately 40%. Dropping from 42 minutes to just 24 to 26 minutes per vehicle. This strategy allows Tesla to optimize international configurations without changing the car body. they can use the same center body shell for all markets. A US domestic version with a standard front and large rear bumper. A European version with a small bumper front end and separate reflectors. An Indian or Southeast Asian version with a rear antenna and more aerodynamic front end. Tesla only needs to produce one type of body center and then attach front and rear components according to market configuration at the final assembly cell. This method, called post-paint final zoning assembly, is currently being tested at Giga Berlin for the Robo-Taxi project. The production implications are staggering. Each production line at Fremont currently maxes out at around 475,000 vehicles per year, but with partial painting and modular head-tail assembly, Tesla could ramp that to over 950,000 cars annually per line. Multiply by 2 lines and suddenly over 2 million Model 2 vehicles per year become a real possibility using just Fremont and Giga, Texas. So, now that you've seen it with your own eyes, this is a full-scale disruption in how cars are built, upgraded, and repaired. From the wheels to the roofline to the rear panels and even the paint itself, every inch of this prototype screams intentional engineering at a scale no other automaker is even close to matching. Do you want us to take more analysis? Drop your thoughts in the comments and stay tuned. We'll come back later. Don't forget to smash that subscribe button and hit the bell icon to join our community of 1,000 subscribers who never miss out on the latest Auto Intel exclusive breakdowns. We're so close to reaching our goal. Help us get there by subscribing right now and becoming part of the Auto Intel family that gets the inside scoop first. Remember to subscribe and help us reach 1,000 subscribers. Every subscription brings us closer to delivering even more exclusive Auto Intel content that you won't find anywhere else.